Hi, good morning. My name is Jose Mora, and I will be sharing with you the presentation of LT series units. And well, right now we have the 10 o'clock, and we will start with the presentation. If you have questions, you can write that question into the chat box, and my coworker Jane will receive all the question, and we will try to answer it as soon as possible. If you need the certificate of participation of this webinar, please let us to know that, and we will send you as soon as possible the information with certification of participation in this webinar. And well, if you can see in a good way my screen on your computers, can you please write yes into the chat box for start with the presentation? And if you can listen in a good way to me, I appreciate you indicate in the chat box. Perfect. Thank you. Right now, I will start the presentation. Okay, we will talk about the LT series. This is a small machines that we are selling for that oil treatment of the transformers oil, and it's a really special series for us. And well, we will start with the presentation. Okay, we know, we all know the transformers are the heart of the electrical distribution system, and it is the high value capital asset around that all the substation. In the event of sudden transformer failure, the consequence of for the customer server as well as the restoration of the system can be very costly. Transformer reliability is of great importance of adequate system function, and unexpected transformer failure can lead the power outage and even cause significant damage to power plants. Power problems with electrical insulation are one of the main causes of transformers failure. Transformers require several electrical insulation strategies to be followed to function properly. Transformer oil not only cools the transformer, but it is a strong dielectric also and prevents occurrences of an electrical arcs be with in the transformer can result from a high voltage. The second fundamental important insulation in the transformer is the cellulose paper, and a large transformers may contain tons of this material as well as thousands of liters of oil. It most function occurs in the internal insulation system. The service life of the transformers is significantly reduced. The transformer does not provide design performance, and negative consequences also manifest themselves in a financial terms. A transformer without moisture in the insulation lasts tens of years longer than the transformer with a moisture content exceeding the permissible values. That is, if the operator wants to maximize the life of the equipment, then the amount of moisture in the transformer insulation should be as small as possible. Currently, enterprise uses several dehydration methods. Sometimes the dehydration performance are not have the desired effect since it was carried out with insufficient understanding of the procedure that they are running. The removing of moisture from a power transformer that has been used for a long time is a task that has been worked for many years, and the many times to achieve optimal dehydration of a long power transformer without moving the later, since the operations have very expensive and sometimes no longer uh, feasible. Okay, and the service of the life of transformer insulation system is determined in the service life for the paper insulation. under normal condition, under normal insulation conditions, the degree of cellulose polymerization is in the range of 800 to 600. That means the paper is in a good way. Um, but as a result of a really high number of influences into the transformer, like uh, the chemical, the electrical attacks to the paper, the insulation aging produced inside of the transformer and thus deteriorates the properties of the paper. The aging does not affect the electrical properties of the insulation significantly, but change the mechanical characteristic in a really huge way. Aging is insulation during equipment function is caused by the influence of a large number of different factors. One of the most important factors influence of the depolymerization of paper insulation is the overheating. When we have a really high temperature around 105 degrees, the paper insulation uh, with moisture start the destruction of themselves. Overheating triggers the process of the pyrolysis on the insulation with the formation of new substances and that enter into the oil and acts like a catalyst in the irreversible process. As a result, the mechanical and the physical properties of the insulation are deteriorated, and therefore the service life of the transformer decreased significantly. The reduce of paper insulation of winding is considerably ended when the degree of polymerization of the paper decreased to 250 units or less. According to experiences of operation organization, a paper polymerization coefficient about 200 units indicate the insulation is unsuitable for work. The new insulation paper polymerization coefficient is about 1,000 to 1,200 units in the polymerization degree. And we have different ways of the cellulose is getting aging and the life of this paper will decrease. And the aging on the insulation during equipment operation is caused by the influence of a large number of different factors. Aging is complex process that includes the destruction of cells as a result of pyrolysis. That means it's a thermal decomposition, and by hydrolysis, that decomposition, the exchange reaction with water, and the oxidation under the action of acids and oxygen inside of the paper. And the hydrolysis and the pyrolysis of cellulose leads to this depolymerization is a result of the both process. Furans derivatives are formed. As a result of the both process, when we are talking about the hydrolysis and pyrolysis, water is formed. That means we can find water when the paper of the transformer is destroyed by itself. Then that means you don't need water getting from the from the outside of the transformer to the inside because the transformers can create his own water in that procedure of the destruction. As a result, the cellulose pyrolysis acid and characteristic gases are released. When we have this procedure, we will find uh, monoxide and dioxide carbon. Carbon monoxide and carbon dioxide we will find in the oil as a result of this pyrolysis. The presence of the latter indicates overheating of the insulation. The main indicators of accelerated aging of insulation are increased temperature, increased humidity of the coiling insulation, oxygen, and oil aging products. A significant indicator of the oil oxidation, even with a low oxygen content, is an increase in content of metals, specifically copper into the oil. And let's consider the influence of some of the listen factor on the aging of the insulation. Destroying as a result of the pyrolysis, thermal aging occurs during the service life of the transformer until the critical destruction of the cellulose insulation and degradation of the mechanical properties of the paper. The aging process is irreversible. As an indicator of the aging of solid insulation of a transformer, its residual mechanical strength is taking. Signs its electrical strength decrease more slowly, and the main cause of the damage of the AC insulation in a transformer is almost always its destruction. The degree of degradation of solid insulation of transformer winding is determined by the degree of polymerization, quite durability. However, its determination requires taking insulation samples from the most heated parts of the winding and involves opening the tanks, which, as a rule, is undesirable, and the operation node is generally unrealistic. In a such case, interleaved metals should play an important role in order to accumulate sufficient data to assess the state of the insulation. When calculating insulation wear, currently apply standards do not take into account much such operation parameters as the moisture content of solid insulation, the contents of soluble acid, oxygen, and aging products into the oil. SIGRE research shows the moisture and the oil aging products, specifically active acids, can speed up the process of insulation decomposition by two or more times. In many cases, the inner layer of insulation adjacent to the conductor appear to be less aged than the outer layers of insulation facing to the oil. Destruction of the result of the hydrolysis, the rate of the aging of paper insulation larger depends on its moisture contents. Moisture present in oil is one of the most important factors affecting the insulation properties of paper insulation. The immediate cause of the decrease of the electrical strength of the oil in the presence of the dissolved moisture in it. However, bone moisture easily turns into dissolved moisture. Therefore, it is considered appropriate to determine the total moisture in the oil. Moisture is associated with the breakdown strength of the oil with the oil paper moisture exchange process. Measurement of relative oil moisture content is continuously monitoring system are carried out using a thin film capacitive sensor. Is with a moisture content of solid insulation of 0.3%, paper insulation is considered well dehydrated and having a full service life. Then, with a moisture content of solid insulation equal to 1%, the aging rate increased 6 times. A standard allows paper insulation to be moisturized to 4%. If all other effects to the insulation for other operation factor being equal, we find that we're with such moisturizing of the paper compared with the basic value of the moisture contents increased by 48 times. Destruction of the result of the oxidation. Okay, the need of the control of oil oxidation and the presence of oil in the oil has been established for a long time. It is known that the sufficiently high acid concentration cellulose can be discomposed into glucose in only 1 day completely. As not about measurement of relative oil humidity are carried out a thin film capacity sensor, which allows continuous measurement during the transformer functioning. Measuring of the oxygen contents in the oil during transformer functioning is difficult due to the high cost of the instrument to monitor gases dissolved in oil continuously. In oxidation, in oxidized oil, the aging rate of cellulose insulation increased by 1.5 to 1.6 times depending on the temperature. An increase of oxygen contents leads to an increase of the rate of the cellulose aging by 3.5 to 3.7 times depending of temperature. Okay. Um, to improve the condition of transformer containing moisture, they should be dehydrated. These procedures are performed on site to minimize transformer downtime and to reduce process costs. To speed up the migration of water, the temperature of the paper must be high enough. However, it's very important not to exceed certain temperature limits to avoid damaging the insulation. It becomes clearly that the key parameter being controlled will be the temperature. Temperature that are too high will damage the transformer, but temperatures that are too low slow down the dehydration process so much that it becomes ineffective. The moisture removal to be effective, many limitations must be taken into account when heating. Sometimes there may be uneven temperature spread inside the transformer. In such case, some parts of the transformers may be too cold and others too hot. Therefore, equable heating in combination with vacuuming is the main factor to improve the quality of the watering, reducing the time required for the watering and slowing down the depolymerization of paper insulation, which improves the mechanical properties of the insulation. The vacuum is also play a really important role in the moisture passing on that table. We can conclude the vacuum is used to extract gas and moisture with the just right or process. We can see here the vacuum in for low molecular density is using for the drying and dehydration and the gassing and the polymer and the impregnation of oil in different systems. Okay, and we need to understand the effects of vacuum and water evaporation and the effect of water and the effect of vacuum and water and why it is so desirable to our process will be carefully examined right now. The first important point is that when water is exposed to the vacuum, the boil point decreases significantly. This makes the possibility to extract water from the oil without dangerous raising of the temperature above 65 degrees, where the oil begins to decompose to form water. It is important to know the value of water vap- vapor pressure, or more precisely, the pressure and the temperature at which water evaporates. When the liquid does not fill the chamber completely, but only at certain level, then there will accurately be two phases of the substance in the chamber. One phase is liquid and the other is gaseous. Uh, the both are made of the same substances. And it is important to know that vapor particles generated from the liquid will act on that liquid in all the directions. These vapor particles located above the surface of the liquid prevent the particles in the surface layer in the liquid form turning into vapor. When we remove the gases particles above the surface of liquid, we eliminate everything that impacts in this superface surface. But particles collision with them with the liquid cause some of these particles to be ejected into the space above the liquid surface, forming vapor. This occurs when the transformer or individual vessel is evacuated. We remove particles that affect the surface of the liquid. This helps particles located in the surface layer to separate from the liquid and turn into gas. It's important that only those particles that are in the near surface layer have the ability to transition into gaseous state. Therefore, thermal vacuum systems then have elements to increase the conduct surface with facility evacuation and accelerate the gassing and okay, so thermal vacuum is used for remove water, for remove gas, and will remove some volatile acid, but not all of these acids. And the thermal vacuum will not work with the removal of solid particles. We will not help out with removing acids. Will not help the restoration of color of the transformer. But we have to remember all the thermal vacuum machines that we sold have solid. Have filters, and this filter will help to remove solid parts from the oil transformer when we are processing it. Okay, the vacuum oil dehydration types we have mentioned several times. The thermal vacuum process is the most common to recovery. There are two types to regenerate vacuum dehydration. The first type of dehydration is the oil when this is sprayed, like in the picture, and this dispersion of the oil in a very fine particles, making it easier to the vacuum act on them. The second type of dehydration of the oil pumped is pumped in a laminar flow, which increases the contact surface and allows the oil to be exposed to the vacuum for a longer time. This process allows the oil to be exposed to the vacuum for a longer and generally produce better results. Also, the racing rings in the pole rings have similar cylindrical dimensions. The Paul rings has the advantage to having two rows of punched holes with incredibly curved tabs, which greatly improves the performance of the nozzles in terms of throughput, efficiency, and pressure draw. We can offer a type of nozzle difference in plastic variation like polypropylene, PVDF, and different other uh, types of components. The capacity of pressure differences most suitable of low pressure drops high productivity, a wide range of size, allow function with optimal efficiency and provide goal throughput. Consider consistent radio of free and blocked passes regardless of direction. Large specific surface area, the volume radio increase the surface renewal rate of the liquid film to improve mass transfer. Uh, the delay of two phases contact facilitates high effective two fast contact and distribution. Uh, Relative high liquid reserve continues to high absorbent efficiency specific in case where the reaction rate is slow. Uninterrupted and consistent pass weight of gas on liquid flow. We have a really high versatility, and the versatility can be looked at by the open stinned designs provide high efficiency use to the surface area in the rings. Also, the resistance of the liquid and vapor distribution, and we will have mechanical strength. And the interval transverse structure of the diameter sparks make the nozzle mechanically strong and suitable for use on deep columns. Okay, when we run out procedures of uh, dehydration, we will different problems when we have service. Um, and the high cost of the process should be highlighted, and that dehydration of transformers is usually structured to electric power companies, which in turn subcontractor this work to specialized companies. During transformer dehydration, expensive equipment is rented and operated having monitored the transformer 40 hours a day. It should be added that during the dehydration process, the power must be redirected to other transformers in the network, since the transformers must to keep up. Therefore, it is clear that the transformer should be dehydrated as quickly as possible. A variety of methods can be used to dehydrate the transformer in the field. The most common method is for force dry hot oil through the active part of the transformer. Often the circulation of that oil is alternate with vacuum cycles. Okay, but it's the problem encoded by the operator. We designed transformer maintenance units as a solution. The unit of dehydration and function transformer was designed. It allows you to dehydrate the transformer directly inside. The design of the column and heater ensures good dehydration efficiency with minimal heat loss, and the increase of the efficiency of the equipment in turn. A simple schema of well-developed operation logic make the equipment easy to operate and does not require trained personnel. The compactness of the system made the possibility of the unit's functional cramped condition, and one worker can move the unit between transformers without additional mechanisms and devices. You can see in the picture that the machine is small. It's really easy and comfortable to move from one side to another, and it's special designed for move only for one person. You can see the place where the people will handle the machine and run out with the machine in an easy way all around. And today we want to talk about our new line of equipment, the LT series. And the line of this series is completely analogous to the standard equipment, but in performance and in the quality of the finished product. The main difference from the standard equipment is the absence of a pressure pump. Instead, pressure pump, we use the vacuum created by the vacuum system in the unit. A wide range of equipment was being developed. The next time we will talk about the main advantage of the equipment in more detail and point out them. Um, we can see here our machine of the series LST, and now takes a closer look at the advantage of the single pump. One of their important advantage is a simplified operation scheme. Simply put, the number of bulbs in the complexity of the piping have been reduced, and this makes the possibility to increase the space of service of the unit in the dimension, as well as to reduce amount of electronic responsibility responsible for the operation of the missing tabs and simplify the operation logic. Let us recall the function of the unit and the same conventional ones with two pumps scheme. Another benefit is reduce the energy consumption. The absence of one pump provides great saving on energy consumption. At the first place, its main thing is that the energy consumption on one pump is not that great. But if we take into account the service of one transformer can take more than one day, then the advance is really obvious. And to this, the several transformer needs to be serviced through the year. And if you add the all together, the big advance is obviously the versatility of the scheme makes the possible to implement it in all existing types of units. Okay, here is a table of characteristics after processing oil with the unit CMM and the CMMU units. Thanks to the use of two-stage vacuum, the system in the CMMU units, we can achieve good results in terms of residual gas contents. And in this important enterprise service transformers, the normal function of which is possible only if a gas content is minimum. After oil flows to the unit, the moisture contents drop to the required minimal level. In case of the high residual moisture contents, it is necessary to carry out several passes to reduce the productivity of the unit. Um, let's first take a look at the CMM LT unit series. The LT series characteristics also correspond to the standard equipment, but the LT is designed to compact dimension. The compactness of the unit allows you to use the crankhead condition in the workshop inside wind turbines, etc. That is in hard to reach place where to not possible to use the standard size equipment. Due that the use of more universal seals, filtering, and nozzles The vacuum column, the equipment can be used to process not only transformer oil, but also turbine, industrial, and other types of oil. The control system is based in a controller. Due to this, the control system is simplified and it is possible to make changes to operating logic without changing the scheme. Due to the use of enlarged input mechanical filter in the installed magnet, this equipment makes it possible to process oil that are heavy contaminated with solid impurities. The filtration fitness of the new housing filtering is 100 to 200 microns. The oil mobile station CMMU is designed to thermal vacuum dehydration, filtration, purification for solid impurities, purification from waters of oil that are used in lubricant system, sealant system, hydraulic control system of gas turbine and gas pumping units, gas motor compressor, as well as a transformer during the function of carry out of the repair work. The unit can be used for purifying contaminated oils from water, free and dissolvable gases, for heating and dehydration, oil-filled electrical devices with a transformer oil using the thermal vacuum dehydration method, method, and for removing soil impurities with the use of the high-efficiency filter elements also. The unit is used by installation, repair, and operation organization involved in process and purification. Um, that's the CMMU, and now we have the CMM-LT series. Characteristics also correspond to the standard equipment. The main difference with the CMMU is the presence of a single stage vacuum system and the presence of control system based on a relay scheme. You can see in this picture here we can find only three buttons. This button will be used to activate the machine, and we can see only one stage vacuum pump. In the CMMU, you can see we have two vacuum pumps, the booster pump and the main pump, and the control will be by a controller. That is the specific difference between one machine and another one. When you have a bigger vacuum system, you will have better extraction of gases because you will achieve better levels of vacuum. But the CMM series is a really good machine, helps you water and gases in a really good way, but is a little bit lighter than the other machine. Okay, here we have the complete set of parts of the machine. You can see where we have uh, placed every single part of the machine. We have the booster pump. Here we have the control panel. Here we have the thermal vacuum uh, chamber here, and we have the oil pump here. And it's a really easy machine. It's really comfortable to work with this machine. All the people in the field are happy when are using this machine. One really important thing in this machine is the vacuum chamber. The main difference of these units from the standard ones is the vacuum chamber is combined with the heater. This made it possible of reduce the unit dimension without reducing the size of the important components. For example, the volume in the vacuum chamber has not decreased, and by using regular pole nozzles, we have increased the effective vacuum in the oil during procedure. And the heater is located inside of the column. You can see here we have the heaters places in this side in the vacuum and thermal chamber, and this this heater is has 18 heating elements installed in it. The heater is controlled from the control panel, and the oil temperature in the heater is controlled using a thermal resistor. The vacuum column is designed for thermal vacuum oil dehydration. The column is filled with a specific nozzle that have developed surface which ensure effective removal of moisture and gases from the oil under vacuum. And we have a really important thing here in this vacuum chamber is the vacuum chamber will create a protection for the heater, and you will have no loss of energy from the heater to the environment because you have in middle of that you will have the vacuum chamber, and that makes the machine is really effective in the energy saving, and you will have really good uh, hot transmission from the heaters to the oil, and you will not lose energy in the environment because you have the vacuum chamber between the heater and the environment. We here have the different components you can find into the vacuum chamber. You will find the heaters, you will find the sensors. For example, here, you will have the high-level sensor, the low-level sensor. You will find pipes to get out oil from the vacuum chamber. You will have the drain pipes. You have the windows to see the oil procedure inside the vacuum chamber. Now, again, you can see here the resistor, and the resistor will have the task to increase the temperature of the oil. You have the electrical bulbs to the control of the vacuum inside of the vacuum chamber. You have the oil trap for prevent the oil pass from the vacuum chamber to that vacuum line, and that will helps you to avoid the mixing of oil between oil of the transformer and the oil of the of the vacuum pump. Okay, we have here the enlarged pre-filter. This is a particles filter, and will helps you to remove different impurities coming with the oil in the inlet line. This pre-filter has magnets in the line, and that helps you to remove metal particles. And this kind of filter is easily to watch. When you have a lot of contaminants inside of this filter, you can release the screws on the cover and move out this filter, and you can clean this with a clean oil. You must to try to clean always these kind of filters only with oil, because you don't want to clean with water, because that means you will increase the moisture inside the system. And the good way for preserve these kind of filters is cleaned oil, with transformer oil. And we have here the fine filter. This is located in the outside and in the outlet of the machine that will pass of solid particles. These are paper filters and are really easy to change between one used and one new one. And we have different components here. You can see on the picture the composition of the filters in the particle filters. Other important things we have is the hydraulic schematic of the machine. This is the schematic of the CMM ULT series. The principal difference you will find with the CMM LT is the presence of two vacuum pumps. You can see here the vacuum pump number 1 and the vacuum pump number 2, where the vacuum pump 2 is a main pump, and this is a booster that will increase the level of vacuum inside the vacuum chamber. And we can see the different position of the different components. Okay, and we can see the filters. Here we can see the mesh filter in the inlet of the machine. We can see the pump. This pump will move out of the machine the oil when the oil is filtering. We can see the level sensor. This is the sensor who activates the function of the outlet pump. When this sensor is active, this pump will start to pumping out oil from the machine. We have the LS2 sensor. When this sensor is activated, the level inside of the machine is too high. That means the machine automatically will close the inlet and will close the line of vacuum for stopping the inlet of oil to the machine. And we have here the LS4 is the sensor dry of the machine. That means if this sensor is activated, maybe we have leaks, and that makes the machine will stop when this sensor is activated. This is the CMMU, and here we have the CMM without the U, and you can see the difference of this machine between the other one is in this one we don't have the vacuum booster, and that means this is a single stage vacuum. All the rest of the machine is almost the same, with the pumps, with the filters, with the sensors. The way of this machine works is exactly the same the other one, but as I say that at first, we don't have the second vacuum pump here, and that's make is a liar machine. Okay, we have different options to add to the machine. We can have um, different sensors. We can add like particle sensors. We can add moisture sensor. We can add system TSS. All these options are to be added to the machine as request. If you want some machine with these characteristics, you will call us and said, "Hey, can you help me with the improve of these characteristics?" And we will help you in the made in the machine special for you. Okay, we can find different different options for monitoring. We have pressure sensors, we have particle counters, we have moisture sensors, and we have oil flow meters. Okay, right now I will stop for a while the presentation, and I will show you a video of one of our friends in GloveCore presenting one of the machines from from our facility. Give me a second. Okay. Perfect. And I will start to run the video. Please tell me if that you can see in a good way with a yes in the first seconds, and I will continue.
Hello, I'm gonna show you CMM1 LT unit. This is the machine of nominal capacity of 1 cubic meter per hour.
I want to know if you can see in a good way the video. No. Okay. Buffering.
It's too slow.
Okay. Give me a second. Okay. Now I will try to do it again.
Let's go through the operational principle and design of the unit. From the very beginning, here we have the ports for inlet and outlet of oil. They are equipped with fast joints of Chemlock types. So oil goes through the manual valve into the mesh filter, which is quite big and capacitive, so you can treat quite a lot of oil before you need to clean it. After that, oil goes through the solenoid valve The solenoid valve is controlled by the level sensor in the vacuum chamber. If oil inside the vacuum chamber reaches this level, the sensor detects it and closes the manual valve. When oil goes down, the solenoid valve opens. In this way, the certain level is maintained in the vacuum chamber. So, through the solenoid valve, oil goes into the heating area. In this machine, heating vessel and vacuum chamber are combined in one module. So, inside the heaters is located, and it is surrounded by the volume of the vacuum chamber. So, oil goes through the solenoid valve in the heating area. It goes up, gets the certain temperature, and then it overflows in the vacuum chamber. Vacuum chamber is filled with the polymer elements with extended surface. So it helps to distribute oil onto the maximal surface, and in this way to boost the process of evaporation and degassing. Now, inside the vacuum chamber, the vacuum is applied. Here you can see the vacuum line. It starts here. The evaporated material goes through the oil trap, through this pipe, to the vacuum pump. And finally, moisture and gases are discharged from here. The vacuum pump is the rotary vane pump with capacity of 20 cubic meters per hour. So it was about the vacuum line. As I said, oil overflows from the heating area into the vacuum chamber. The vacuum is applied, the moisture and gases are removed, and finally oil is discharged by the gear pump. Here we can see it. So oil is taken from the vacuum chamber and passed by the gear pump through the block of fine filters. This is first one. The second one. So oil goes through the fine filters, through the non-return valve, to the outlet of the unit. It was about the flow of the oil and the material exhausted. Now, a couple of words about the additional sensors. We have already told about the level sensor for detecting of oil and maintaining a certain oil level in the vacuum chamber. We also in the vacuum chamber has the foam sensor. As soon as the foam is detected by the sensor, the operation of vacuum pump is interlocked. When foam level goes down, sensor goes off, vacuum pump starts automatically. Now, the other sensor we have in the oil trap. If for some reason oil is captured by the trap, first of all you can see it in here. If you missed this moment to stop the unit and drain oil, the level sensor will detect the presence of oil and stop the operation of the unit completely. To resume the operation, you need to discharge, to drain the captured oil from the oil trap. A few words about the gear pump and its piping. Actually, the piping has two bypasses. One contains the safety valve. This is done to prevent overpressure in the outlet line of the unit and followed piping. So it is usually set on 5 bars, and it means if for some reason the outlet line is closed, I don't know, maybe some valve is closed, the pressure raises, and if it reaches 5 bars, safety valve opens and oil will be passed to the inlet of the gear pump. In this way we prevent overpressure in the unit and followed outlet lines. This was about the first bypass, safety. To the heating area, to the inlet of the unit actually. In this way you can decrease the total capacity of the unit, and this is advisable when you work with very wet oil, which can cause severe foaming. So, safety bypass and capacity control bypass. About the control panel. Here we can see the buttons for turning off, on and off, for vacuum pump, oil pump, heating. Here are the buttons for activation and deactivation. We also have here the indication lights for power presence, correct phasing, indication of heater operation, and some alarm situations such as overheating, oil in tray. I will explain it later about this sensor, and oil in tap. We have already said about this. So, oil in tray. We also have the floating sensor in here. If oil is collected in the tray, the floating sensor goes up and provides the alarm signal. So it was about the oil and tray indication. The unit has temperature controller to control operation of the heater. As the option, the unit can be supplied with the moisture sensor. It is located in here. It is located in the outlet line of the unit. It helps to monitor the quality of the process of drying. At any moment you can print the result of measuring. Now about the control cabinet. The electrical parts are from well-known suppliers such as Siemens, ET, Italweber. Besides of the said before, I'll also mention the presence of vacuum gauge. So it controls the pressure inside the vacuum chamber, and the pressure gauge to control the pressure in the outlet line of the unit. With this gauge we measure pressure after the oil pump. So that was brief review of CMM1LT unit. We also produce the machines with capacity of 2.2 cubic meters per hour and 4 cubic meters per hour. They have a very same design, with the only exception that the pumps and the heaters are of bigger capacity. So that was about CMM LT serial units of GoCore. Thank you.
Okay, thank you for your attention to the video. I will continue with the presentation. Okay. Well, we are really close to finish the presentation. We will talk about a little bit about the system TSS, and the TSS is a system that we use to work with the transformer working online. This TSS have the possibility of serving the transformer with the transformer turned off. The transformer, we will have the level monitoring of the oil inside of the transformer. If we have reduction of the level, the system will stop automatically, and if we have increase of the level, the system will stop automatically. We have the possibility of connection in any equipment, but we need the possibility of connect the pressure level. That means you can work any transformer online, but you need the specific point for the connection of the sensors, because this sensor will send the information to the system of the level of the oil inside of the machine. And we can achieve levels of automatic automatic levels of the connection via GSM. That means you can monitoring the procedure even you are far from the machine. That means you will have the possibility of see what is happening with your transformer even if you are not close to the procedure. Another things we have here is the all transformer oil analysis systems. We have different components like the oil moisture meter TOR1. We have the breakdown voltage TOR 80 and TOR 100, and the hydrogen and moisture analyzer TOR 2, and the oil tank and tan delta TOR tester TOR 3. All these kind of equipments are really small and really easy to use, and are really good complement for work in the field. When you are running out procedures of reconditioning the oil or dehydration, the gas in oil, you will need to know if your procedure reach the desirable values, and that means you will need some equipment for helps you to understand you are running in a good way the procedures with the thermal vacuum machines. That or one is a really good option if you need to uh, check the levels of moisture inside of the oil you are working, and it's really easy. The weight of this equipment is really low. You can see 6 kilograms, and that means you can work in an easy way in the field. And these equipments are really precision, have a really high precision. We have a really good results in the field when we work with that TOR number one. Other equipment is the breakdown voltage tester TOR 100, TOR 80, and TOR 60. That numbers is equal to the kilovolts you can reach with every single model of the TOR. It's a really easy to work with this um, tester, because it have pre-programmed the different standards that will work, and that means you have the easy way with press a single buttons. You have the procedure running in the field, and that TOR 80, TOR 100, and TOR 60 can work by batteries, and that gives you the possibility to made the test in the field. You can even program your own procedures, not only the standards. You can make your own procedure for the test of the oil if you want. You can make different programations, and you can adjust the existing programmation of the different standards. Uh, Other important instrument that we have is that turn number two is exactly the same like turn number one, but this has the opportunity to make a measurement of hydrogen inside of the oil. That means if you are running out the gasification process in the field, you can have information at the moment when you are running these procedures. You will see the information in the screen, but you can also print a report of the measurement running out with this equipment. And we have really intuitive commands and really easy to use the equipment. And we have the oil tan delta tester. Tor 3 is a really small equipment used in laboratories, and you will control the procedure by the computer, and you can run the procedures depends of the different standards. One important thing is this equipment has the heaters for increase the temperature of the oil, uh, like the different international standards ask you. That makes you will need some time for reach every single measurement, but when you reach the temperature, the machine will run in an easy way the measurements of the tan delta. And we have a lot of advantage in the machine. You can see it's a light, it's compact, it's easy to use, and you can set different settings for different purposes when you want to make different research and looking for some information. We present to you the series LT, and in a really fast way, we present the different oil tester analysis, oil testers of the Glovecor company, and we hope you enjoyed the presentation. If you have any question, please let us to know about that, and we will try to send you the answer to your questions by mail. If you need information about our machines, don't have don't don't forget to send us your email, and my friend Jane will answer you as soon as possible. And from my side, is all. And I appreciate your attention, and I hope this presentation was good for you. And I hope to see you in the next webinar. Thank you, everybody.